A warm welcome to all of you for today's session. Myself, Dr. Sumathi, working as an assistant professor, PG and Research Department of Physics, the Standard Fireworks Rajaratnam College for Women. Today we are going to see about the topic Ocean Thermal Energy Conversion, which is OTEC, under the subject of energy physics. So let's see one by one. The cover topic of today's session is introduction about OTEC, what is the working principles of OTEC, and what are all the types of OTEC, some of the advantages and disadvantages, how the benefits of OTEC from the upcoming sessions, and then the limitations, finally the futures of the OTEC. So let's see one by one. Let's see some of the introduction about the OTEC. So what is OTEC? It is a renewable energy technology that uses the temperature difference of the ocean to generate clean and reliable electricity. Generally, energy from the sun heats the surface of the water of the ocean, and those surface of the water can be warmer than the deeper water. This temperature difference which is used to produce the electricity. So this is the working principles of OTEC. When the sun rises, fall and reach the surface of the ocean, the surface tension increases. Here we can see the surface tension is increases. When the surface of the temperature is increases, which is about 30 degrees Celsius, and when we go to the depth of the ocean, which is about 1000 meter, the temperature of the ocean remains low about 10 degrees Celsius. So with the temperature difference of 20 degrees Celsius, we can generate electricity. This is the two infinite heat reservoirs. So the next one is, there are some classifications of OTEC. One is based on the cycle type, another one is based on the location. Based on the cycle type, there are two types. One is open cycle plant, another one is a closed cycle plant. Here based on the location, there is a land-based plant and another one is a offshore plant. So let's see briefly about the open and closed cycle system. Here the open cycle system is also known as cloud cycle. So this is the basic fundamentals of how the open cycle systems will be working, and this is the block diagram for the open cycle system. So the temperature of the water here, the temperature of the water of the ocean surface remains high because of the intensity of the light produced from the sun. Then the surface water flows into the separator, and the separator is through the pipe. This separator is used to convert the water into the steam. Then those steams are strike-ons to the turbine blades. As the result, turbine starts to rotate. Alternator or another name is generator, which is denoted here as A, which is used to help to rotate. That alternator converts those turbine rotates, which is mechanical energy, into electrical energy, and those generated electricity transmitted near the grid of the distribution purpose. Also, when the steam strike-ons to the turbine, pressure of the steam reduces, so it will follows on to the condenser, and those water again send back to the ocean, and send back to the ocean. When the steam comes into the condenser, the steam converted into the water, and those water again split up into the ocean. Again we take the heated water from the ocean. Again the same procedure will follow for the separator. This cycle was once again produced and the next cycle will go on. This is the way for the electricities are produced in the open cycle system. And the next method is closed cycle, which is also known as a Anderson cycle. Here this is the basic fundamental ideas about the Anderson cycle. The closed cycle, open cycle and closed cycle, the only difference is there we have used only sea water. Here we have used the ammonia, propane, or for the chemicals for their working fluid. And this is the block diagram for the closed cycle plant. The next one is a closed loop system, which is almost similar to the previous one, that is a open cycle system, but there is a only difference is here we had used the ammonia liquid as a main fluid. Here it is used as ammonia liquid. We can take the heated water from the surface of the ocean and exchange those water into the ammonia liquid, receives heat from those reservoirs and from the heated water. When heat transfer into the ammonia liquid and then it is vaporized and it converts into the steam, those streams are again strikes onto the turbine. With the steams, the turbine starts rotate, as well as alternator is also rotates. So again alternator converted mechanical energy into the electrical energy, and the steam flows on to the condenser to cool for the cooling purpose, where the steam flow towards the condenser, and again steam converts into the liquid ammonia and flows into the heat for the next cycle. The same cycle repeated for the electricity was produced. And we can see some of the advantages over the OTEC. Here the power development is continuous and it is very clean and no air pollution will be conducted. It is very suitable for renewable and sustainable energy. It also conserves the fossil fuels, and it doesn't need any transportations, and simultaneously we can produce desalinated water for the many other purposes. And it also has some of the disadvantages. Initial cost can be very high, and the efficiency is very low, which is about 2.5% whole, as compared 30 to 40% of efficiency of conventional over the power plants. The large setup size was needed due to the low efficiency. That is the main disadvantages. Even though it has some of the disadvantages, the many benefits are there. One is we can consume constant power 24/7. We can reduce the dependency of fossil fuels. That is most important benefits. Next, which is cost effective, very cheaper than most other alternative energy sources like some other renewable energy sources. It is a huge resources potential, up to 88,000 terawatt hour per year we can produce. Numerous uses besides power generations. So it has some other limitations. First limitation is the area was with the annual thermocline of 20 degrees Celsius, political concerns over locations, disruptions of the ecosystems. These are all the limitations, and beyond that limitations we can conclude that some of the futures of OTC, there are many companies are there for the future OTC. One is ocean thermal energy conversion from the private corporation limited, Blue Rise, some of US company. Another one is Rainwood and Mackay Ocean Engineering and Lockheed Martin. So some of the upcoming projects are approved. From India there is an Andaman and Nicobar Island. There they can produce the electricity using ozone thermal energy conversion. From two of the islands from US, one is Hawaii and another one is a Virgin Island. There they can produce the electricity, and another one is from France, which is the Reunion Island, which is also used to produce the electricity by using OTEC method. Thank you for watching this video. Thank you.